everyone, I'm MARIFA. I will be talking about case study 2, security. What is computer security? Computer security is also known as cyber security and IT security. It is a protection for computer from theft or damage the hardware and software. Today we will be discussing about one type of malware and hacking. Malware is a program that disrupts the computer, and hacking is gaining unauthorized access to a system or server. Today's topic is rootkit from malware and pixel-perfect timing from hacking. Now I am going to pass the stage to HK.
Thank you, Marifa. For today, my presentation is rootkit. A rootkit is a type of computing software which can access to an unauthorized user to steal his information, and it can hide its existence. It is also known as malware, which damages computing system. It is very hard to detect because it can overturn the software that wants to find it out. So it's very easy for it to hide the computer. The detection method to find it out is by using an alternating operating system, signature scanning, and memory dumping method. So removing of rootkit is very hard when the rootkit resides in the kernel. So restoring the operating system is the only way to solve this problem. This is all my part now. I'm going to pass my stage to MAHEDI. Thank you.
Thank you, HK. Today I will present the history of rootkit. How we get the name rootkit. Rootkit is actually maliciously modified set of administrative tools for Unix-like operating system which guards the access of root. Rootkit it was first documented in 1986, and in 1999 the rootkit was first documented for Windows NT. And for Mac OS X, it was discovered on 2009. Next. Now I am going to give some famous examples. Sony BMG copy protection rootkit scandal is one of the great example of rootkit hacking. And there is another one, Greek wiretapping case 2004-5. Now I am going to talk about type of rootkits. There are four type of rootkits. One is user mode, another one is kernel mode, the third one is hypervisor level, and final one is firmware and hardware. I can explain the hypervisor level more. In hypervisor level, the operating system runs in a virtual machine. It actually modifies the bootting system. And for next slide, I am asking Mr. Luke to present the slide. Thank you.
Good afternoon, I'm Luke. Okay. Here I will give a brief example how the rootkit is going to work. So as you can see, we're using the MAC here as a type of rootkit that we're using. This is a user mode rootkit. Well, we'll create a story. There's a guy named Whitehead and a guy in black hair. So here the Mr. Black, he wished to access the Mr. White his own computer for the sweet data. But how is he going to do it? So at first, so he using the matrix. But first, he gained to the Mr. White computer, and he got his own root or the user and password. But the thing is, how is the Mr. Black going to maintain his own root, password, and user? Well, here's the matrix come in to work out. So now Mr. Black is going to manually install the matrix rootkit inside. So how is it going to work? First, the matrix rootkit, he will rewrite and replace most of the system command to get his own username, password, and so on and so on. So here you can see the matrix is create own password. So username will be root ROT, and password just random generic number 123456, and port number will be 237 and 23. Okay, so the matrix will automatically install inside the Mr. White computer. So he just generate, copying, and create the password, the report, and so on. Now, Mr. Black got his own access code, aka the backdoor. Now, as you can see, this is the matrix work itself, and the matrix will automatically delete itself after all the installation is complete. Now, Mr. Black will get access to Mr. White's computer without Mr. White noticing it. He can control all the data, and he can get like something like maybe your credit card number, personal ID, maybe some of the secret project you're working on. So this is how the rootkit work on. Okay, but the thing is, can we detect or defend against rootkit? Now, here we are using the same computer that Mr. Black is the rootkit inside. Now, Mr. White is suspecting someone might have hacked my computer, so he using a software called Rootkit Hunter. If you check the computer by checking on computer with a check out command, so he just checking out. Wow, he found out he have 9 suspected files here and 3 possible rootkit. Oh my, my computer has been hacked and someone has gained the root. So, here's the thing. Well, rootkit is really a big nasty protection. It doesn't mean that we cannot defend against it, but the thing is, once the computer is infected, you just can't simply just remove it, because if you write and replace your system command, it's inside the kernel mode. So the last thing you can do is just hope you have some backup file, your important backup file, and reinstall your system again. So rootkit in modern days, it wasn't just a malware. It was combined with using the other malware as a shell and cover to a rootkit function. So this is how the rootkit works. Thank you. And now I will pass up to my friend for another part, hacking skill, pixel perfect timing.
Thank you, Rob. And I'm now going to talk about what is pixel perfect timing attack with HTML5. And first of all, we can know that actually pixel perfect timing is a number of timing attack techniques that can be used on malicious website. The most important is to steal some sensitive data like your password and etc. other things. Next. And we now are going to talk about the history of pixel timing attack, which the 3 point you see here is actually the idea history that is from pixel timing attack. First one, let's see forcefully pick up CSS property of a link. As you know that which app's website, actually they have their own element and stuff. And if we visit a link, the website, usually the link will be painted purple. And next is to calculate the time needed to a random page. If you realize that sometimes if you visit a web page, it's slower than usual. It's because it's the first time you visit a web page, because the information of the web page is not yet stored inside the cache, as you see. And the last one is using a HSTS vulnerability to sniff browser history. And this method is especially very efficient when used against JavaScript. Next. And this is a famous issue we are going to talk about. For now, pixel timing attack has not done anything serious attack yet. Who knows, maybe tomorrow. And next, pixel timing attacks usually documented by Postal in July 2013, and also demonstrated by Black Hat at the same year. And now I'm going to pass it to Nicholas.
Thank you, Colin. Now, as stated earlier, pixel perfect timing attacks is just another form of browser timing attacks. But for this pixel perfect timing attack, we're going to be using this request animation frame method. Using this code, we can differentiate between we can tell the time it takes to render one frame to the other frame. Now you have to understand the rendering process of a website. So before the website is displayed, the web browser has to actually paint the website, and before that, it has to render the whole website. Now, knowing that our code can differentiate between the time needed to render one frame to the next frame, so we can input something like a white image here. After we superimpose these two images, we will get this noisy image, after which we apply the hero filter, we will get this noisy image. But this image is not the important part here, but rather it's the time needed to render this image. Now, let's say we input a black element in here. After we superimpose, we will still get a black image. And if we apply the hero filter, it will still become a black image. But since uniform colored images, as said earlier, would render a lot faster than noisier images, the time needed to render this image will be also a lot faster. So, knowing that our code can differentiate between white and black pixels, we can read text from a website. Now, in Mozilla Firefox, the source code of a website can be loaded onto an iframe. So this is the iframe here, and here is the source code. The source code of a website will usually contain sensitive information like a user's username, password, email address, security certificates, or authentication tokens. By applying the filters earlier onto the source code, inside the web browser, we will get something like fast pixel, slow pixel, and then a few more fast pixels. So we can create an algorithm which can analyze these slow pixels and build up an image of the source code. Now we just need to know the location of which the sensitive information is located inside the source code, the font used by the source code, as well as the size of the characters. Now, as you can see, using this algorithm, we can create an image of the source code, and the web browser can steal sensitive information without you actually doing anything. Now, is there any way to prevent this from happening? Actually, as of now, there really isn't any way to prevent a pixel perfect timing attack, as browsers have already optimized to render these noisy images earlier, and all these things earlier combined to allow this attack to happen. So what the question here is actually whether we trade off speed over security. Now that question hasn't really been answered yet, so I'm just going to end the presentation now, and thanks for your time.
Thanks for your time for listening to us about our key study security. So, any more question to us? No? Thank you. So, please like and subscribe, and if you have anything to ask, just leave a comment below. Okay, thank you.